This is now N double bond and OH. So what we will see now. Hello everyone, welcome to PLUTUS STEM. Today we are going to discuss the next video in which we will discuss regarding the preparation of aryl halide through aniline. In the previous video we have discussed how we can prepare these aryl halide from benzene. Today we will see how these can be prepared through aniline. So this aniline is a nitrogen containing compound and has two when directly linked to this benzene ring. This is our aniline, and when this aniline is being reacted with NaNO2 HCl, NaNO2 plus HCl, and that some lower temperature is there, which means that some cold, you can say the temperature should be lower, or you can say 0 to 5 degrees C. The temperature range should be low in this case. What we are going to get over here? We will get a very important N2 positive, Cl negative, and this compound is diazonium salt. This compound is diazonium salt. So this diazonium salt, it is being prepared, and when it is being reacted with CuCl2, when it is being reacted with CuCl2HCl, or many other way we will discuss in the next upcoming slides. So it will produce like this. This is the method. There are various other reagents are there that we can do copper plus HCl, like that. We will discuss what are the ways through which we can prepare these alkyl aryl halide through this aniline. The first thing which we will discuss in the today's lecture will be how we can prepare this. So if you are not that much interested, you can skip this mechanism part. But those who are interested, they are preparing for JEE Advanced. For them, this mechanism is also quite important. So how this reaction proceed? We will see over here. This is in this mechanism. We will see that NaNO2 reacts with HCl. NaNO2 react with HCl. It will give us simply this one, HNO2 plus NaCl. This is being produced in the in situ. We take this NaNO2 plus HCl and we get the HNO2. In this process, we are getting HNO2. So this HNO2, what is happening over here? If you see the structure of OH and double bond O, this is our HONO2. So if you see this HONO2, the most important thing which we are going to see now, we will produce an electrophile type thing which is NO positive. From here we will generate NO positive, HON double bond O over here. When it is being attacked with HCl, H positive of HCl, when attack over here, the H positive of HCl will attack at this portion, and we are going to get over here HOH, a positive charge, single bond and double bond O. Now you have already seen that we are getting a positive charge on this oxygen. So what it will do, it will take the electron like this. So water will be liberated over here and we will get N double bond O, a positive charge. We are getting over here N double bond O and a positive charge over here. So now what you will see, this aniline, now the real reaction come. Now the real reaction is coming toward us. This aniline, the lone pair are quite reactive. They will react with this N double bond O positive charge. They will attack over here and we will get a product like this. Clear or not? But one more thing over here, we will have a positive charge. So in the initial step, we have taken a H positive. Now it's time to release that H positive. Now it is the time to release that H positive. And what we are going to see over here, this will be relieved over here. And we will get NH and double bond O. So now this is the way how we are seeing over here. And this step what will happen now? Now the tautomerization take place. Now the tautomerization takes place. So what will happen over here in the tautomerization? We know this electron will move over here and this hydrogen will come at this side. Like in the alkene, aldehyde and ketone we see this hydrogen, it came over here and it goes up over here, there, and this bond comes over here and this hydrogen take this place like this. In the same way you can see it is coming over here and it is taking this place. 1, 2, 3, 4 over here, 1, 2, 3, 4. At O we are getting this hydrogen attached and this O double bond O is coming over at this side and this is bond is coming becoming a double bond. So in the same way like we are having this ketoenol, this way we are getting a tautomerization is taking place over here. Yes, so this tautomerization taking place and we are getting a product. This was just for you for understanding. Yeah, just to recap the concept. Yes. So now what we are going to get over here, we will get a product N, single bond, double bond N, single bond O and H. This is now N double bond N OH. So what we will see now, there is a H positive is there. So that H positive will be attacked by this now again. The relieved H positive will be attacked by this. And we will have N double bond N OH2 positive. Because of the presence of acid, now this will leave down and we will get N double bond N. Over here a positive charge and the Cl negative, if you remember, in the first step we have leave this Cl negative. H positive is there, so Cl negative is also there somewhere. So that Cl negative will come over here and will remain like this. And this can be also done like this. This thing. This is the way. So this is the diazonium salt. This is the preparation of diazonium salt. How we can prepare the diazonium salt? I have shown you over here. How we can prepare this diazonium salt. In this video we have seen how to prepare the diazonium salt from aniline. NH2 NaNO2 HCl 0 to 5 degree C, or you can say cold, we are getting N triple bond N, positive charge, Cl negative. This is a diazonium salt, and this is a very interesting and important reagent that is being used in various reaction, in which we can produce enormous number of organic compound are being produced with the help of this diazonium salt. This diazonium salt help us to prepare an enormous number of organic compound. So now we will see how we can prepare what are the various way how we can prepare by through this diazonium salt, or it is better if we just simply write down the simply, no need. N2 positive and Cl negative diazonium salt when react with Cu2Cl2HCl, Cu2Cl2HCl, we will get Cl like this. Or another way, if we react with CuClHCl plus CuClHCl, then also we will get the same product, aniline. Aniline to this Cl negative, Cl halide, aryl halide. So this is the way how we can prepare. If, and this mechanism, this way, this reagent, if we are using this one or this one, so this reagent is known as Sandmeyer reaction. These are being reaction was given by Sandmeyer. So this reaction is known as Sandmeyer reaction. Sometimes you can be asked through a name reaction. This is a Sandmeyer reaction. This is a Sandmeyer reaction. One more type of reaction of this Sandmeyer. N2 positive Cl negative Cu2Br2HCl gives Br, bromobenzene. The same reagent, if we are taking with Cu, the first reagent is this one, CuBrHCl, then also we will get the same product, either this one or this one. So both are going to give us the same bromobenzene, and these are, you can call it them as a Sandmeyer reaction. There is one more type of reaction, that is Gutterman reaction. So there is a slight difference in the reagent of this Gutterman reaction. In this you will see, when these diazonium salt react with CuHCl, when these diazonium salt react with CuHCl or CuHBr, these are the two ways I have shown you over here, CuHCl or CuHBr. So we will get chlorobenzene and bromobenzene. These can be prepared through this method, and this method is known as Gutterman reaction. The only difference is here we are using Cu2Br2 or CuBr. In this we are taking simply copper with HCl over here. In this case we are using HCl and HBr. So these was the various way how we can prepare this aryl halide, or you can say aryl chloride and aryl bromide For aryl fluoride, we are having a different way in which the name is known as Balz-Schiemann reaction. N2 positive, Cl negative, HbF4 negative. When we are using a reagent HbF4 negative, then we will see that this is giving us a aryl fluoride. So this is also a name reaction, and the name is Balz-Schiemann reaction. Balz-Schiemann reaction to prepare this aryl fluoride. So these are the various ways. In the today's lecture we have discussed how to prepare these aryl halide. So I am going to summarize all those which we have discussed in the today's class. Firstly, we have prepared this diazonium salt from this aniline, and I have shown you this mechanism also over here. Firstly, this N double bond O positive, and electrophile is being generated. This electrophile is being attacked by this aniline, and we after the rearrangement and tautomerization, we get a diazonium salt. This diazonium salt, when react with different reagents, we are getting the different product, and they are being named by the or named on a different scientist, such as Sandmeyer and Gattermann. So the reagent are different. Copper with HCl and copper with HBr. This is known as Gattermann. And when Cu2Cl2 and CuBr or Cu2Cl2 and CuCl react with HCl, this is known as Sandmeyer reaction. And for Schiemann or Balz-Schiemann reaction, HbF4 negative with diazonium salt give us a fluoride. So this was like a few important reaction which we have discussed for this aryl halide formation. In the next upcoming videos, we are going to discuss various properties of alkyl and aryl halide. So be continued with this channel, and we are going to cover up the whole your class 12th and 11th chemistry with the extent of this JEE and NEET syllabus. We are covering all the concept also. That's why I am explaining you the mechanism, the drilled mechanisms that will be very useful in your JEE advanced point of view. So be continued with this video series. That's all for today. Yeah, thank you.